In today's class, we are going to come across on operations of matrices. We all know that what is a matrix? A matrix is nothing but a rectangular arrangement of numbers or even the functions. Keeping this point in mind, today let us study the operations of matrices. As we all know how to add two numbers, subtract and multiply the numbers, may be real or complex numbers. On the same way, even we can add two matrices, subtract the matrices. But one very important condition for to add or subtract the matrices must be of equal order. We can't just add any two matrices or subtract according to our wish. That is not possible. We can add or subtract the matrices only when the given matrices are of equal order. Equal order means in sense same order. With this, let me start the first operation called as addition of matrices. Here, in general, I have considered two matrices. The matrix A equal to containing the elements Aij, whose order is n cross n, and the matrix B is equal to the matrix containing the elements like Bij, whose order is also m cross n. It is very clear that two matrices A and B are of equal order, then only we can add the matrices. To add the matrices means what? They must be of equal order, not only equal order, the corresponding elements must be added. For example, A is equal to 1, 2, 3, minus 4 and B is equal to the second matrix -1, -3, 4, 0, then A plus B will be equal to. Just add the corresponding elements. 1 minus 1, when we add, it leads to 0. 2 minus 3 is -1. 3 plus 4 is 7. -4 plus 0 is -4. Hope you are observing. I have just added the corresponding elements of the two matrices whose orders are equal. This is 2 cross 2. Even the matrix B is also 2 cross 2. So A plus B also will be 2 cross 2. This is called as addition of two given matrices A and B. With this, let us see few properties on addition of matrices. The first property is commutative property. What do you mean by commutative property? If I add A plus B, I am getting that result. On the vice versa, if I add B plus A, then also I will get the same matrix itself. Such type of property is called as commutative property. That is, if A is equal to the matrix containing the elements Aij and B is equal to the matrix containing the elements Bij, whose orders are m cross n itself, then the commutative property states that A plus B is always equal to B plus A. It is very similar to our real numbers. For example, if I take two numbers 2 and 3, we all know that 2 plus 3 is same as 3 plus 2. So, with this we can conclude that addition of matrices is commutative. Important point to be remembered by the students that matrix addition is commutative. Addition of two matrices satisfies the condition, satisfies the property of commutative law. Let us move on to the second property of addition of matrices called as associative. Now, in place of two matrices, I am going to consider three matrices. Let A, B and C be three matrices. Not only three matrices, one very important condition it must be that all the three matrices must be of equal order. Equal order means what? If I consider the matrix A as 2 cross 2, even matrix B also must be 2 cross 2, and it's very much understood matrix C is also of 2 cross 2. So let A, B and C be 3 given matrices of equal order M cross N. Then what does our associative law states that A plus of B plus C is equal to A plus B plus C. This is called as associative axiom of addition of matrices. 2 points very important to remember is addition of matrices. Addition of matrices satisfies commutative law as well as associative law. What is commutative law? A plus B equal to B plus A, and associative law to be remembered for the matrices is A plus of B plus C equal to A plus B plus C. The third very important identity law, or also called as identity matrix. I'll just consider a simple matrix A. Let A be a single matrix and O be another matrix. What is O? Very simple. O is nothing but the null matrix, which you already know in the basics. Here O in general stands for null matrix. Let A be any given matrix, O be the null matrix, then what does our identity law states? It states that A plus O equal to O plus A is once again equal to A. You are observing here, when we add a given matrix, with the null matrix, we are getting back the same matrix itself. So only here, null matrix is called as additive identity. Point to be remembered here, null matrix is called as additive identity matrix. Let me clear here, if A is a matrix of order 2, then even the null matrix also must be of order 2 itself. Why? Because addition of matrices can be applied only when both are of same order. We cannot add 2 matrices if they are of unequal orders. So, if A is a matrix of order 3, then it's very much understood that even the null matrix must also be of order 3 itself. This is called as identity law. A plus O equal to O plus A is equal to A, where A is our given matrix and O is the null matrix. Not only that, what is this O called as? Additive identity matrix. It is called as additive identity matrix. So till now, students, you have come across the first operation of matrices called as addition of matrices. We can add the matrices provided the given matrices are of equal order. Addition of matrices satisfies commutative law, associative law, and even it has an identity matrix, that is under identity law. Now, let us move on to the second operation on matrices, that is nothing but subtraction of matrices. All know that how to subtract 2 numbers, right? Not only 2 numbers, real numbers, it can be even complex numbers. On the same basis, now let us try how to subtract 2 given matrices. As usual, I am going to consider 2 matrices A and B, where the matrix A is equal to the matrix containing the elements Aij. B is another second matrix, given matrix, which contains the elements Bij. Once again, the same rule applies even for the subtraction also. Remember that. Just we cannot subtract any 2 matrices that we have in our hand. No, that's not possible. We can just subtract any 2 given numbers without much thinking. We just subtract them, right? But that is not possible with our matrices. A and B must be of equal order. Very important point here. if you want to subtract two matrices, then it is possible only when A and yes, subtraction of matrices is possible only when A and B are of equal order. So I have considered M cross N be the order of both the given matrices. Then how the subtraction of two matrices is usually written? It is denoted like this. Yes, it is denoted by A minus B. And how to subtract? Same basis. In place of A plus B, we write it as A minus B. And subtract the corresponding elements and subtract the corresponding elements. I just show you one example how to subtract two given matrices. I will consider 2 cross 2 itself. 2 minus 3, 1, 0, minus of minus 1, 2, 3, 4. Let us subtract them. But before subtracting, whether the first condition what I said satisfies or not, let us check it out. Here A is 2 cross 2 and even B is also 2 cross 2. So what does A minus B gives us? 2 and its corresponding element is minus 1. Minus 1 minus into minus becomes plus 1. 2 plus 1 is 3. Minus 3 minus 2 is minus 5, right? 1 minus 3 is minus 2. 0 minus 4 is minus 4. And once again, purposely I am writing its order also. The order is 2 cross 2. So if the given matrix A and B are of M cross N, remember students, even the subtraction resultant matrix will also be M cross N. Same thing happens even in our addition also, isn't it? These are the points to be remembered so that it will help you in your competitive examinations. When I add A and B, the order of A and B, that is A plus B, will be same as A and B. When I subtract A minus B, I get the same order like 2 cross 2 itself. Now, let us just glance what about its properties. As we all know that commutative is not possible with respect to our subtraction. Why commutative is not possible? Because basically commutative is not true with respect to our numbers, so it cannot be even true with respect to our subtraction of matrices. Is not possible means what does it imply? Just glance the properties. In case of subtraction of two matrices, A minus B is never equal to B minus A. A minus B is never equal to B minus A. Subtraction of matrices properties, A minus B is never equal to B minus A because it is not true even for our real numbers. On the same basis, it is not true even for the matrices. Point to be remembered is subtraction of matrices is non-commutative. Important point. Subtraction of matrices is non-commutative. Once it is non-commutative, it's understood that subtraction of matrices is even non-associative. It's non-associative. It's true only for addition of matrices, but not for subtraction of matrices. A minus B is never equal to B minus A. Till now you have come across two properties on matrices, operations of matrices, addition of matrices and subtraction of matrices. On the same basis, let us proceed now for the third point. Very good one, it is scalar multiplication. What do you mean by this scalar multiplication? We will try now to multiply a scalar, an independent number, and insert it into a matrix. Multiplying a real number with a given matrix is called as scalar multiplication of the matrix. It is called as scalar multiplication of the matrix. Let's consider let K be any given real number and the matrix A is equal to the matrix containing the elements Aij whose order is given by m cross n, whose order is given by m cross n, then its scalar multiplication will be multiplying every element of the matrix A with the given real number is called as scalar multiplication of the matrices. Let us consider one example with respect to our above concept. Here I have taken one 2 cross 2 matrix, hope you are noticing it, which contains the elements 1, 3, minus 4, 5. Now I want to multiply this matrix with the scalar, that is nothing but multiply the given matrix with the real number 2. Then how to do that? I will write this 2 as it is and the matrix A. What is the matrix A? 1, 3, minus 4, 5. Then that will be equal to, as I said, according to our theory part, multiply 2 to every element. 2 into 1 gives us 2. 2 into 3 is 6. Minus 8, and this is nothing but our 10. So this is nothing but multiplication of a given matrix with our scalar. So till now you have come across 3 properties: addition of matrices, subtraction of matrices, and scalar multiplication of a matrix. All these 3 I am going to just summarize it up using a problem. Just take up this one problem. Here the matrix A contains the elements 2, 4, 3, 2 whose order is 2 cross 2. Matrix B is 1, 3, minus 2, 5, 2 cross 2. Then matrix C is minus 2, 5, 3, 4 whose order is 2 cross 2. As I said, all the 3 matrices satisfies our condition, the main basic condition. What is that basic condition? We can add or subtract it on the basis that all the matrices are of equal order. Yes, all the 3 given matrices are of equal order. So, we are going to calculate now A plus B, A minus B, and then 3A minus C. In all these 3 bits, we will come across all the 3 operations till now what is explained to you all. Coming to the first one, the first bit is A plus B. What is here? What is the operation stands here? A plus B means we are going to add 2 matrices with their corresponding elements. We'll just concentrate on A and B now. We have to add the corresponding elements. So, 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. What is its order? The order is once again 2 cross 2. Now, let us consider the second bit to be calculated, and that is A minus B. Here, A minus B stands for subtraction of 2 given matrices A and B. Let us now try to subtract the corresponding elements. 2 minus 1 gives us 1. 4 minus 3 is once again 1 itself, doesn't matter. 3, be careful students here, it's already 1 minus here. Minus into minus gives us plus. So, 3 minus of minus 2 is 3 plus 2, which gives us 5. 2 minus 5 is minus 3. So, this is nothing but subtraction of 2 given matrices A and B whose order is 2 cross 2. So, what I am trying to tell is not only subtracting the corresponding elements, anyone can do that easily, right? Even you have to check, even you have to go through its order also. A and B are 2 cross 2, even the resultant matrices are also 2 cross 2 only. Third one, we are going to do 2 operations together. You might be thinking, which are those 2 operations? Here it is, 3 3a minus c. So the first one is scalar multiplication. We are going to multiply 3 with the matrix A and even subtract with the third matrix C. So what is 3a minus c equal to? Already a is given. First multiply it with 3. 3 into 2 gives us 6 and 12. This is 9 and this is 6. Let us write down the matrix C once again. Minus 2, 5, 3, 4. What will be the required matrix? The resultant matrix is 6. Minus into minus is plus. 6 plus 2 gives us 8. 12 minus 5 is 7. 9 minus 3 is 6. 6 minus 4 is 2. So this is once again 2 cross 2. This is our value of 3a minus c. So here in this problem, we have come across all the 3 operations. Now let us consider a second problem using addition, subtraction and even scalar multiplication of the matrices. The second problem is we are supposed to find the two matrices x and y. X and y are two matrices must be obtained using the given data that x plus y is a matrix of order 2 containing the elements 7, 0, 2, 5 and x minus y also they have given. X minus y contains a matrix 3, 0, 0, 3 which is once again a matrix of order 2. If you just observe it carefully, there are nothing but two equations with the two unknowns. Which are those two unknowns here? The unknowns are not the variables but the unknowns are the matrices x and y. Just concentrate on the steps thoroughly one by one step. Here what I have done, I have first added the LHS in and while adding the LHS maintain the terms in the parenthesis. X plus y plus x minus y is equal to the first matrix plus the addition of the second matrix. And what happens? Plus y and minus y cancels with each other. X plus x gives us 2x. On the same basis, now let us shift to our RHS part. Adding. What do you mean by adding? Just now we have come across. Add the corresponding elements. What is the corresponding element of the 7? 7 plus 3 is 10. 0 plus 0 is 0. 2 plus 0 is 2. 5 plus 3 is 8. Do we need the matrix 2x? No. We need the matrix x. So in order to get the matrix x using our scalar multiplication, I will divide both sides of the equation by 2 by the scalar 2. 2x will lead to only x. Then what happens? Let us check to the entries of the matrix. 10 by 2 is 5, 0, 2 by 2 is 1, 8 by 4. So we have reached our first stage of the solution, obtaining the matrix x. This obtained matrix x of order 2. Now I am going to substitute in the first equation of the given first equation. X is written, which is just now obtained, 5, 0, 1, 4 plus y is unknown, so it has to be maintained as it is, equal to the RHS matrix. What will be y equal to? RHS matrix minus the matrix on the LHS. Subtract and we get the matrix y.